Starting
Yes,
at
please.
the end. Okay, so then we try and start. So we're going to look at Ghana soil classification system and its relationship with the word reference base. So this is what we are going to look at today. So let's start. Uh, so soil classification, what is it? Why is it necessary to classify soil? Those are questions we need to ask ourselves. Then as we go along, we appreciate this all important question because in Ghana, we have so many agroecological zones, or let's say ecological zones. And each of these ecological zone has its own unique, what do you call it, soil characteristics. And this soil characteristics supports specific types of crops. So it's very, very important for us to understand the spatial distribution of soil in relation to its chemical and physical properties. So that when you want to go into any agricultural projects, you know that in this region, this crop will do well. In Western region, this is the kind of crop or plant that I need to cultivate over there. So let's see the universally there is difficulty when it comes to classification of soils. We have so many types of mode of classification out there, but then we will emphasize on some few of them, then move on. So let's see. So soil classification, what is it? Is the systematic categorization of soil based on distinguishing characteristics as well as criteria that dictate choices in use. So these are the first working definition that we have. Then as we go along, you realize that in soil science, a natural system approach to classification of soil is normally used, and this is based on their intrinsic properties. That's morphology, the soil, when it says soil properties, um, the morphology, the nature of the soil, sometimes the behavior. Then we also have what we call the genesis, the history of the soil formation itself can be uh, used, or the timeline for information can be used to classify the soil type. So this result in the classes that can be interpreted for many um, diverse use in soil science. So the key things that we use is the one is the property, behavior, then the history of the soil itself. So these are three key things that we use in soil science to classify soil. But then we have different generics when it comes to classification. We have the USDA, we have the word classification systems and FAO and the rest. So and then we also have Ghana, the Bremen classification system. So we talk about that later once we go along. So as I said earlier, there's no worldwide unified classification scheme for soil. Americans have their own way, and those in the British colony also have the way they do classify soil. So we have what we call the word reference base, is international standard for soil classification system endorsed by the International Union of Soil Science. So please take note of this. So let's say, and under this we have at least 26 sub-classification under the WRB. We have 26 soil types. And I'm not going to go through them. I'll just mention them on the go. Then when you are interested, you go and then read about them. So you have something like acrisols, endosols, arenosols, and the rest. There are so many of them. Chinozymes are found in the Ukrainian plain. Then we have the Fibisols, Basoils, and the rest. There are about 25. So if you want to know more at the global scale, when you have time, just try to use a map and identify areas where we can find this type of soils. So this is the continuation, about 23 of them. I'm not going to talk about them in detail. So if you are interested, you read. Then let's look at what we have in Ghana. That is what we call interim soil classification. And this is based on Bremer, 1962. It's very, very old classification. Sometimes you still see them in textbooks. So let's try and then understand what it is. Under this classification, we have what we call the Ghana classification is based on the USDA soil, then International Cooperative Soil Survey, soil taxonomy. Then, and this system recognize the following levels of soil classification. We have order, just as we have in plant and animal nomenclature. So we have order, we have suborder, we have soil group family, we have gray soil group, we have gray soil subgroup, then soil series. If you come to Ghana, we have what we call Akuse series, Takawenia series, and the rest. These are all forms of soil classification system under the so-called Bremer classification system. So the order, let's try to understand these key terms. What is the order? The order are differentiated by presence or absence of diagnostic horizon of features that show the dominant sex of soil forming processes that have taken place. So what is diagnostic? So diagnostic horizons are soil layers with specific quantitatively defined properties used in soil classification. So when we say diagnostic in soil science, that's what we mean. And that is what we normally refer to. The suborders differentiated primarily by what? Chemical and then physical properties that reflect either the presence or absence of waterlogging or genetic differences due to climate and vegetation. So this word is different from the genetics that we know. It comes from the word genesis. So let's look at the great soil group. These are defined by presence or absence of what? Diagnostic horizon and their sequence in the profile. So the way the layers of the horizons are organized can be also used to classify a soil type. Then number 4 says the subgroups, and the subgroups usually come with the suffix and the prefix like typic, osic, etc. So the subgroup identified as the function of soil group, which rank as central concept, with the subgroup being integrates either to the other what we call groups. And normally, if you see a subgroup, it starts with either this word, osic or typic. We shall come across a lot of them as we go along. Then we also have the family. The 5th one is family. This criteria at family level are soil properties observable on the lower part of the profile that are important to growth of plants, such as texture. We talked about that earlier on, mineralogy, pH, consistency, and then permeability. So based on these attributes, You can also use it to classify soil. Then we have a series. This is the lowest conceptual soil category, grouping soils with identical profile. So you look at the profile and say this soils are the same, they are not the same, they fall under the different soil groups. So let's look at the USDA. In the case of United States Department of Agriculture, they also have about 12 orders. And then one of them is the officers. And these are predominantly what they're soil, what agalic horizon. And what is agalic horizon? An agalic horizon is defined as subsurface soil layer characterized by significant accumulation of alluvial clay. So if a soil has this attributes, it can be described as an aphysol. One of the things chemically you have to look at is the presence of iron and aluminium. And when you have presence of iron and aluminium in the soil, it sort of contributes to high level of acidity of the soil. And this is the typical characteristics of some of the soils in the tropics. And we are saying that it has high cation exchange capacity. What it means, the CEC means the cation exchange capacity, and normally form under broad leaf forest ecological zones. Then we have andisols. These are formed from volcanic ash and defined as containing high proportion of glass, then amorphous colloidal materials. Then we have aridisol. The word is derived from arid. That tells you that this type of soil forms under dry environmental conditions. Then we have the antisols. These are very young soil. When we say a soil is very young, so that comes under the genesis, old, young soil. Then we are trying to say that or describe the nature of the profile. Young soils with little or no profile development. So when we say soil is very old, then that soil has well-defined profiles. Then that soil is very old. Then we have the clay soils, and these are forming under what? Very cold climatic condition and contain gel-like permafrost. What is permafrost? These are what they call a frozen soil throughout the years, throughout the what do you call it? Even when it is summer, such soils are always frozen. And this is very, very common in the Siberian regions of Russia and part of Canada, where you have extreme cold conditions. So their soils are very cold climates and contain gel-like permafrost within 2 meters of the soils. So such soil, if you expose them as a result of climate change and then high temperature elevation, what is happening is that such type of soil develop sinkholes. We tend to have a lot of sinkholes because we end up losing this part, the permafrost region, and then develop into a sinkholes. Then we have the heterosols. These are very rich, consist of organic material such as peat soil, and you find them in areas like Norway, Sweden, and Finland. They tend to have high peat. Peat is just like another derivative of coal. In some countries, they use it to generate energy. Then they have the insectisols, soil with altered horizon that have lost material by leaching. So if there is high, and this type of insective soils are very common in the tropics. So then we also have the mollisols. They have a thick superficial horizon or epipedon. Well, what is epipedon? What do you call it? Epipedons are surface horizons, which most often uh, identified by what do you call it, analyzing the way the horizons are organized. And sometimes they are very rich in calcium, and then of course saturated organic matter. So molly soils are very rich in organic matter, and then usually associated with temperate grasslands. Um, so they also have the abscissols. They are characterized by low cation capacity exchange and low base saturation and extreme mineral weathering. So these are the attributes. Then we have the spodosols, a typical soil of coniferous forest. So where you have a conifers, there's likelihood that you come across the spodosols. Then ortisols, um, and the vertisols. Those are all types of one of the key characteristics of vertisol, the cementite clays, and this clay tend to crack and expand, and it just behave like a Monte Morronite clay. When it swells. When it is dry, it's develop cracks in them. So let's look at Ghana classification system. In Ghana, in the Ghana soil classification system, um, the factors of soil formation are more central than the concept of uh, diagnostic horizon as contained in the what USAD soil map of the world and well reference base for soil resources. So here we normally in Ghana we look at the environment, the factors leading to the formation of that particular soil that you are dealing with, and we use that to classify soil. And this is under the so-called Bremer classification system. So sometimes it is referred to as the interim classification. And we have basically four orders, namely climatophytic Fs. That tells you that this type of soil is influenced by the climate. So climatophytic F are well-drained soil in the legacy interim Ghana soil classification system, whose formation and characteristics are considered to have been predominantly influenced by local climates and what? And vegetation. So the drivers leading to the formation of this type of soil are what? Climate and vegetation. And we use that to classify this type of soil. Then we have a topoclimatic earth. Topoclimatic earth, you can guess. Of course, this is not a standard scientific term. It refers to soil's property and formation have been significantly influenced by local topoclimate. And of course, when we say topo, we are referring to the relief and the configuration of the land surface, such as inclination, exposure of slope, altitude, the presence of valleys or depressions. So we use that to describe soils in Ghana. Um, then we have topo hybrid, that's combination of water and then relief. Also can be used to describe soil. Then we have the lithochronic. This is basically the color of the soil is also used to classify soils in Ghana. So please, I would urge you to focus more on this because this is basically related to Ghana. And so you take them seriously. Let's see. So let's decompose that into small units and let's see what we have. So we have what we call under this. If you take climatophytic Fs, the first one we want to talk about is the agrobeds. These are thoroughly rich soils. The soil percolates water. The soil is percolating water reaches the water table without much what accumulation of basic cation in the profile. So you realize that the influence of the water table in this type of soil is very, very paramount. Then we also have xeroped. And these are soils of the climatophytic earth that are not thoroughly leached. Isn't it? Leaching is less in those type of soil. The wetting front does not reach the groundwater table. So in the first case, you realize that the water phase, the wetting phase reaches what? The water table. The second one, zero part, it does not reach the groundwater table. So two groups have been identified at the sub group family level. We have the latisols, highly weathered soil with a clay fashion dominated by 1-to-1 clay, that is kaolinite clay, iron and aluminum oxides. Then we also have what they call basisols. That tells you it's more or less alkaline in nature. This is purely defined class. They represent soil with considerable amount of valuable minerals and in part of the soil profile. So this under the xeropod, you have two subclasses, or what they call the subgroup family, vertisols and then basisols. Basisols. So please take note. I always like to mention this type of soil because a lot of research has been done on this type of soil, Montemoronite. And normally it falls under the so-called Akuse series. So if you go to Pong area, Akuse, starting from Tema towards Akosomo and the rest, you come across this type of soil. You see them on the Accra plains. Ideally, they are very fertile. Last time I mentioned it, and they are very plastic, and they are very difficult to work with when they are wet, and when they dry, they crack. But then they contain high levels of organic material. So now let's look at topoclimatic. This order comprises soil whose formation is due to mainly to climate and relief. And in theory, some people will say that they do not exist, but then it's also believed that you go to mountainous regions of this country, you come up to some extent, you may come across some of them. Amadufere, the coal mountains and the Ebri areas of the country may come across the topoclimatic earth. Usually, they are not well developed because of the terrain. They sit on rocky environments. On top of rocky, the profiles are not well defined because of the nature of the terrain. Then we have the topohydric, the morphological and then physicochemical characteristics of these soils are primarily influenced by relief and, of course, drainage. So the combination or the synergy between the relief and the drainage that we have tend to influence this type. They have what impeded drainage. Some of them do, but not always. When we say impeded drainage, meaning that movement of water through set type of soil is not so rapid. Under the carbohydrate Fs, we have 5 orders, and these are planopeds. The word you see, the word plano, meaning that it talks about flat land. These are poorly or imperfectly drained soil, as induced by what flat topography, peneplains, and river terraces. So you may have them on the river courses when the speed of the river is very slow as it's trying to discharge into either the sea. So places along the estuaries of Ankobra, Kano, this what they call Praia, the rest, you may come across the planopets. Then what the planopets, this comprise, climb means that on the surface of a slope, this comprise soils occurring on the slopes that are influenced by lateral seepage of water from upslope following a recharge or discharge phenomenon. So, the movement of the water along the slope also is a factor that influence this type of soils, and we classify them under planopets. So let's look at another. We have the word depression pets. It tells you that these soils are formed in depression. These are developed in depression, a poorly drained externally, or in parts of the year. So they are what they call the epi-saturated. Almost throughout the year in the depression, you tend to have some amount of water is set around. If it's poorly drained, then it means that they may form under waterlogged conditions, or the water table is very high. So let's say then we have what they call hydropets. These are soil developed in open water, for example, shallow lagoons, permanent swamps, and lakes. Then we have the comlopets. These are soils developed in depressions where peats, and particularly in Ghana, we don't have this type of thing. Peats are not very common here, or they are virtually absent, where peats has accumulated. Then let's look at another set of classification, that's litochronic. Litochronic F uses color of the material to lithochromic or chromic F refer to natural occurring F material whose color is directly inherited from the parent rock material. The term lithochromic or chronic is primarily used in soil science to describe soil color that has been significantly altered by biological or chemical forming processes. But when you use that term, that's the meaning. So the development of these soils are mainly influenced by parent material, the time over which the soils are developed. The profiles of these soils are generally immature. I think I said that earlier on. The specific factor that cause the young nature of the soils are used to group them into into sub-orders. So we have chronic or lithochromic classification. So we have a lithopets. The profile development is restricted by rocks that are relatively resistant to weathering. So if you have a set situation, you may not have well defined soil profile. So at balance of soil erosion over soil accumulation on steep slopes. Then we have the rugopets. The parent material is poor or inert. Example, loose sand. The soil group family is called rugosols. So if you have like a soil that we have along the beaches, a typical example of rugopets, they are poor and they are not inert. When you say inert, most often they are not fertile because they are devoid of organic material. So if they are purely silicon-based material, we describe such soil rugopet. And such soils, such environment, you have people normally go there to win soil for building construction. So where you have this type of soil that we can use to move blocks, then you are dealing with the rugopets. and they are all over central part of Accra and part of Brahafo. So the soils of Ghana at the Great Soil Group level. Now we have another group, another classification. This is the very old one. We call the forest acrosols. We have the forest acrosols, or yeah, and this acrosols are type of soil normally found in the tropical regions, particularly in Ghana, that are known for being fertile and then, of course, well drained. They are sometimes characterized by a thin dark topsoil and a thicker reddish yellow brown subsoil with what? Clay accumulation. Acrosoils are classified in two main types. We have the forest acrosoils in wet southern areas. Then we also have the savanna acrosoils in drier northern regions of the country. Then we also have, as I said, so we have savanna acrosoils, forest acrosoils. Then we have the oxysols. The oxysols are highly weathered tropical soil found in warm, moist climates, characterized by their deep, well-drained structure and, of course, low fertility. Then we also have the ground water lightrites. These are a form of reddish soils. You normally find them in the northern part of the country, and they are highly resistant to water percolation. So we have groundwater lightrites. Then we have the tropical black clays. A good example is the moronite that I mentioned. Then we have the tropical grey elf. So let's look at where in Ghana we can find this type of forest acrosols. These are deeply weathered soil found in semi-deciduous forests and part of the forest savanna transition agroecological zones of Ghana. These zones stretch from west to east along the middle portions of the country across the Volta Lake. The soil profiles are matured. So if they are mature, so meaning that you have well-defined profile, often show clay accumulation in the subsoil. They are suitable for what? Cocoa, coffee, oil, palm, and then para rubber. Of course, the plantation crop production. They are very suitable for those productions. Yam, it can support yam, cassava, and maize. Then we have the savanna acrosols. These are similar to the forest acrosols, except that they occur in what? Savanna area with semi-arid climatic conditions. They support what? Cereals like maize, sorghum, millet, of course, cowpea, and it's also ideal for tip and tree crop like cashew. So if you have such type of soil, those are the agricultural activities that you can carry out with those soils. Then we have oxysols. These are soil occurring high rain forest zone of the country and are restricted to southwest. So we are talking about the western region of Ghana. And oxysols are they are highly acidic. One thing about them, they are highly acidic. Though these soils are commonly found in areas that receive annual rainfall amounts of what? 1,800 millimeters and above. They also found in areas that receive annual rainfall amount of about 1,600 millimeters on certain geologies, such as the Tacowanian cossacks, well, sometimes the Tacowanian series. Then this type of cossacks, especially if you study the distribution of gold in Ghana, wherever you have this rock, you tend to have some level of gold in them. So only acidic tolerant plant crops such as tolerant plantation crops such as oil, coconut, para, rubber, coffee are grown. So that's the main reason why the extremely low, southwest of Ghana, very close to Alibo and other areas, although they have high amount of rainfall, normally they don't plant cocoa because of this acidic environment. So it's not suitable for cocoa production. But then It has there for coconut, then para rubber. You go to Bonsa, you have miles of uh, para rubber plantation. So then groundwater electrified. These are commonly found in the interior savanna zone of northern Ghana. They are mostly associated with the Oceanian shales and Boitic complex granites. They occur on gentle slope topography in the plain landscape. They are shallow to moderately deep. The soils are generally pale brown to pale gray sandy loams, which contain between 10 to 40% iron stone. So if you have iron concretions, it means that drainage is, drainage is a problem. And nodules to depth of about 60 centimeters. So because of this, we say the ironstone concretions, wherever you come across this type of characteristic, said soils are poorly drained. During the raisins, if you go to the some part of the northern region, within a short time, when it rains, the place becomes flooded. It can be there for some time. The water will stay on the land for some time. But then when it is dry, it's actually dry. The land becomes so dry that it is not able to support any agricultural crop unless you use irrigation. So those are the types of soil that we have. And it is very good for most often rice production. Groundwater laterites are well known for their poor internal drainage condition, as I said, that induce temporary water logging condition during heavy rains. Suitability for agriculture, we have maize, sorghum, millets, groundnut, and kapi, of course, bambara nut. Wetland rice is locally grown on the low-fat terrain, which are inundated during the wet season. At such sites, the soil grade savanna lattice soils are very common. So that's why in the northern region you come across large scale rice production, unlike the southern parts, whereby we have most of our rice production in the valley bottom. If you go to western region where you have wetlands, more or less valleys, you see them growing our local rice because that environment is able to support the local rice type. So then we also have this type of soil we call tropical black clays. They are mostly found in the coastal savanna zone in the Accra Ho-Kita plains. Normally, the Accra Ho-Kita plains start from Winneba up to Aflao. That stretches along the coast of Ghana up to few kilometers inland. They are developed over basic needs in a general gentle topography. They are very dark brown to black clays. Whether next is encountered within 120 centimeter depth. Most profile contain calcium carbonate concretions, and these are scattered in the subsoil. Calcium carbonate, that is an indication that such soils can be alkaline in nature. So please take note. Suitability for agriculture, the main limitation of this soil is their workability. They are very heavy, plastic when wet, and very hard when dry. They can only be plowed within a restricted range of soil moisture content. And that is difficult to attain under rain-fed agriculture. Apart from a few thousand hectares that have been developed for irrigation, for example, Asitare, Afife, and Tong irrigation projects, the bulk of these soils are rarely cultivated because of what this condition, that the plastic nature of the soil. Rice and sugar cane are the main crops on the irrigated field. Small patches of rice field are also locally cultivated during the wet season. So that is it. So if you have the tropical black clays, a good example, I always mention Montemoromonite. Then we also have the tropical gray earth. These are soil found in the Accra Rokita plain, just as the tropical black earth. They develop over acidic gneiss and schists, especially on lower slopes where they are locally influenced by drainage. Suitability for agriculture. The presence of hard pan within what 30 centimeter depth is a serious physical limitation to what road development. So you need to plow. You have to plow this type of soil. If you don't have implements to do that, supporting meaningful agriculture becomes an issue. You either use a heap, what they call mounds, in order to plant on them because of this limitation. So topsoils are naturally low in nutrients. The topsoil, which are relatively richer, is basic cations are inaccessible to plant root. These soils are used mostly as open grazing fields. Open grazing fields. Other great soil groups, we have the latisols. They are found both under the forests and savanna vegetation. They are shallow, brushy soils developed on steep slopes or over extensive exposures of hard rock and iron pan. This is where you go read on this. What is iron pan? What are the factors contributing to formation of iron pans in the soil? They have very little agricultural value. Then you have the regosols. They are restricted to narrow strip along the coast of Ghana. They are deep sand developed in a probable coastal dome landscape. The soils are highly acidic, poor in nutrient, basically composed of quartz. The regosols are normally used for molding, what they call it, blocks in cover sandy soils. They are therefore generally of low agricultural value. However, support good coconut plantation, especially in the southwestern Ghana, where annual rainfall is over 1,800 millimeters. Then we have the clay soils. They occur along few major river basins, Volta, Nasia, and Ofin rivers. They occupy terrace positions and are rarely inundated by the presence of river floods. The soils, due to their alluvial nature, vary in texture, color, and reaction. They are locally used for vegetation and then, of course, sugarcane production or grazing, meaning that you use this type of soil support livestock production. Then we have the groundwater polysols. They are developed in old infill lagoons locally identified along the coast in the southwest. The profile consists of about 5 centimeters of humus stained sand over about 60 centimeters of bleached sand that is abruptly underlain by dark organic pan. Below the pan, the soil is gray to brown sands. So you have the Atuabo series is an example of this type, Atuabo. And what do we have in Atuabo? Who can tell me? What is in Atuabo? I hope my tree is correct. Anybody in the class? What do you have here? Atuabo in Ghana. What is the major thing there? Major economic activity in this town?
Atuabo thermal plant. Or is it?
I will talk about that. Anyway, well, you people should try and identify key landmarks in Ghana. You are going to teach geography in senior high school. Is that also? Or is it JHS, social studies in DSS? JHS, I don't know.
No,
Some of
senior
you
high
know it.
school.
Excuse
Hello,
me.
Prof.
Yes,
Atuabo gas plant.
yes, that's it. So, um, then we have sodium village soils. This saline soil that border the saline coastal lagoons. They stretch eastward from Songo Lagoon to beyond Kita Lagoon to Togo border along the Ghanaian. Here, where you get to this area, around the Kita area, they are able to use the sodium very source. What they do is they incorporate the soil with and that small fish, I don't know, we call it the Kita school boys or whatever, and guano to support that small types of onion, shallots. So they use basically this type of soil is able to support a shallot production in Kita area. They are black to dark clay with hard, sticky consistency, and well noted for the presence of salt crusts on the soil surface, especially on the bare land bordering the margins of the lagoon. But then with the help of what they call it, indigenous knowledge, let me put it that way, they are able to use it to produce shallow. The soils have limited agricultural potential. They are, however, cultivated to sugarcane around the lower water basin where they receive influx of fresh water annually, thereby reducing their the sodicity. The sodicity means the level of salt in the soil. It measure the salt concentration in the soil. Then this one, olive soils, first they are normally found where you have streams. They are soil bordering most of the rivers and stream network in the country. The other recent alluvial deposit or presently influenced by floods of this drainage, which we get to in Sawam, along the Densu banks. That type of soil supports a lot of sugarcane production. Um, and now that because of the climate change, you really see that Densu floods it banks. But in the olden days, it floods the banks, and immediately the river subsides. They start cultivating along the banks, and it brings a lot of silt from upland and deposit them along the banks as a result of floods. And most this type of soils tend to be very fertile. They are locally for wetland rice and sugarcane cultivation. Dry season vegetable garden is common in some areas. So now let's look at Ghana classification and compare that with the well reference base. So when you see parasols or acrisols from the well reference base, we are referring to oxysols. So when you see something like laxisols, olysols, then you are also referring to acrisols. So laxisols can also refer to acrisols. So in that order, grand nitride is called pranatosols or pranosols. So tropical black clays are called vertisols or glacisols. So these are the comparison. So where you see so this column refers to how we classify under the Bremen classification system in Ghana, but at the international level, we can also classify that same soil using this the following names. So, for example, you have the litisols, we call liptosols, sodium very salt, we call sonochucks. the rugosols become rugosols. I think they are the same here in this particular condition. So let's look at geographic variation soils and vegetation distribution in Ghana. So we have soils of the rainforest. These soils found in this area are forests, oxysols. We talk about them. The color of this soil ranges from brown to orange. They are porous, red rain, and generally loamy. They are developed with a wide range of highly weathered material. The high rainfall in this area leads to severe leaching of plant nutrients. The leaching has made the soil acidic, and the dominant grain mineral is the kaolinite. And what is kaolinite? Kaolinites are more or less aluminum silicon based clay. If you look at the chemical structure, it is sometimes laid silicate mineral that forms from weathering of what aluminum rich for like the feldspar, known for its heavy feel and low hardness. On the Mohs scale, you can read them on 2 on the Mohs scale. They use in products like paper, ceramics, and cosmetics. They have 5 colors, most often just like what we call in our local language as much as shire also. And it has a lot of industrial application, particularly in the ceramic industry. Sometimes along Cape Coast, you see the ceramic company in Takoradi carrying some of them. They don't know where they go and then extract them, but you see the heavy duty vehicles transporting them along the highway for ceramic products. Then soils of the rainforests. So we continue. So if you look at the soil geography, you realize that this is the distribution. So you see these shallow bits. These yellow bits are all acrisols. Then you tend to have light blue, this one here. These are lovisols. Then you have the mix. The red is either we have the gray soil. The gray soils are restricted to Kita area and part of Alibu Azim area. Isn't it? So this map will help you to identify exact locations of some of the soils in this country. So let's say, so the soil of the moist semi-deciduous forest. This region is dominated with soils classified as a forest agrosoil. We talked about this already. These soils developed in the same highly weathered material mentioned above, but because of the low rainfall in this zone, they are not as highly leached as the roots oxysols. They are red or brown to yellow. These soils are rich in plant nutrients, but often have concretion layers at the shallow depth. Please read what is concretion. Take note and read concretion. What is soil concretion? What is soil pan? Read all those terms and then concepts. So the dominant clay, as mentioned, as a kaolinite. Then we have another one, the soils of the interior wooded savanna. That is the Guinea savanna. Let's talk about them. The most extensive soil in this ecological zone are groundwater light-rich soils. They cover nearly 75% of the region. This soil developed over what? Vosgian shales and sandstones. They have cemented layer of iron stones at shallow depth that impedes what? Penetration of water. So whenever you see iron stones, iron pan concretions, then it may have issues of water penetration. The soil range in color from combination of yellow, brown to yellow gray. This type of this portion of the course is more of practical, and the field you have to visit the field so that you can actually
appreciate what we are talking about. It's something that cannot be done online like this. Another important soil group in this area consists of savanna acrosoil. The soil differs from the forest acrosoil by having less organic matter and nutrient. Why is it that in savanna the soils have low organic matter as compared to those in the high forest zone? We can explain. You have grass in savanna, you have forest what do you call it? Vegetation in the forest zone. So what a tree bless a tree plants in the most of the forest zone. So why is it that these two factors contribute to variation in observed amount of organic and nutrients in the savanna soils and then the forest soils? Please try to understand the mechanism. Rather than the savanna, because of high biomass accumulation and leaf litter, you tend to have more organic matter in the savanna soil and forest soil. In the grassland, you have only grass, and really, do you see that the grass will shed their leaf? So you have low biomass, and of course, there's another major human problem: recurrent annual fire, bush, fires, will also destroy most of the organic matter in the soil. So you have low plant biomass accumulation in the savanna region as compared to the forest zone. So soils of the southeastern coastal savanna, there are several soil groups in this zone. Coastal savanna, lateritic sandy soil, tropical black soil, tropical gray soil, sodium gray soils, and coastal sandy soils. The coastal sandy soil consists of pale yellow sand, often without a surface layer of humus organic matter. So ideally, such soils are usually used for molding blocks in the construction of our buildings. The coastal savanna crystals are similar to the soil found in interior wooded savanna, except that they are not as acidic. So the tropical black clays, or black or dark brown or dark gray, this word it should be gray. It's not like that. Please check the spellings. It's not A, it's E. They are developed over basic nicks. These soils are heavy and plastic when wet and hard and compact with cracks when dry. They are alkaline and may contain lime in lower horizons. They have abundant amount of calcium and magnesium. The dominant clay is what? Silicites. So please take note. Let's look at another topic: soil fertility, soil survey, and land evaluation. So soil surveys are meant, what are the functions of soil survey? I don't know whether I'll go through everything, but let's see, what are the functions of soil survey? Why is it necessary to conduct soil survey? I think that's a very good question. So let's judge on this. Yes. Look at help. Should I mention names? Nobody want to speak. If you don't want to speak, I will set questions on them on the soil. Class, are you with me? Let me escape from the presentation mode so that I can see your faces. Okay, so I'll set question on the importance of soil survey. So let's see. If you don't want to talk, then I'll force you to answer them.
a soil survey to investigate the geographic distribution of soil that occur in a given area. And that is very, very important. It helps you to identify and locate where certain soil types can be found. To determine the most important characteristic of the soil, that is also okay, because it's not just location, but you also link that with the physical and chemical attributes to what? Delineate map units and describe them in a logical ledger in terms of dominant associated inclusion soil units, including classification of soils. So how many points? Soil surveys ultimately lead to evaluation of the quality of different map units for specific types of land use. Soil survey apply the principles of what soil science and draws information heavily from what? Geomorphology, theories of soil formation, physical geography, analysis of vegetation, and land use patterns. Then another thing is that let's look at the principles of soil survey and draws heavily from soil property. One of the things that is the backbone of soil survey that it relies so much on soil property. Soil survey works usually include what? Clay mineralogy and certain phases of soil chemistry and physics, as well as formation on improved method for dispersion of tropical clays. So it draws heavily the principle of soil surveys where it takes samples and want to classify the soil on the basis of spatial distribution. You look at those attributes. Then it also provides vital information in the face of conflicts over potential land use. Soil survey at various levels may be needed to provide pertinent information about the comparative suitability of the kinds of soil for farming, rainforestry, and then of course housing. So there are so many things that we need to understand before we can use a soil type. So soil survey provide this essential information. Then need for soil information. Priority for soil survey areas require consideration of factors such as the acuteness of the need for soil information. Is it necessary at all to conduct soil survey? Who is going to uptake this information? There should be the principles based on, so that will guide your objective in collecting information during the survey. So the benefit to be derived, the number of people involved, and the ability to make direct use of the information, and the problems faced by the soil survey team. So these are these are things that you have to consider as part of the principles of soil survey. Then when you want to do that, one of the things that you need not to lose sight of, that the capacity. Do you have the capacity to do that survey? So training of local personnel at various levels to carry out all phases of soil survey should be regarded as a continuing part of the long-term program. And this can be achieved through what? Fellowship. Where's the fellowship? Giving people opportunity to upgrade themselves in institutions. Then, of course, those already who have the skills, because the discipline keep on changing. You need to attend conferences to apps in terms of current techniques and skills that are being used in the discipline of soil science.
So then there's something called the approximations. And what is it? The 7th approximation scheme of soil classification. The 7th approximation scheme of soil classification appear to be the most satisfactory system of soil classification to use, because the categories are defined precisely, and yet there's flexibility to permit a change if needed. And what is it? Please read on this 7th approximation scheme. Now, let me give you just a brief information about this. The 7th approximation scheme is an anti-system classification system developed by US soil survey staff, which was a precursor to the modern soil taxonomy system. It was characterized by its set for genetically significant properties, high degree of precision, hierarchical, mature, exclusive structure that face limitation in its application, logical consistencies leading to its replacement by soil taxonomy. So this is the background information with respect to this approximation. It's a scheme of soil classification systems that are being used in classifying. Although it allows this flexibility for it to be modified to meet local needs, to tailor to see the local requirements. So this principles should be a guide when you want to conduct a soil survey. Then you need to also draw inferences, correlation of soil type with the kind of interventions that need to be made to improve its performance in terms of its ability to support crop production. So the result of fertilizer application need to be correlated with the kinds of soils in which they were made, so that the information will have water application through the use of the subsequent soil maps. So not just identify the soil types in the local areas or geographical zones, but also try to correlate additional information with those soil types, the kind of crops that they can support, the types of nutrients that are deficient, what kinds of intervention to be made in terms of application of fertilizer, and all kinds of chemical interventions that need to be made with respect to that particular soils, need to be incorporated into the information during the survey process. Then let's look at survey methodology. What goes into survey? What are the methods? What are the things that you need to do? During the background study, all relevant data on the target area are compiled. So you cannot rely on your own knowledge on the field, but you need additional information from other sources to enable you to do a very thorough land survey. So you include information like studies, existing studies by other researchers, existing maps, and most importantly, aerial photograph. And aerial photographs are sometimes in the form of mosaic, meaning that they are cut into pieces. So you need to find a way to bring them together as a continuous unit so that you can use it to describe what is happening on the ground. So aerial photography, aerial photographs glued together as a full cover mosaic may serve as what? A base for ground truthing. When we say ground truthing, you have to do a field work
thorough field work in support of what you observe from the area photos. So assessment of soil variability can be done in different ways. So ground truthing is very, very important part of stereoscopic interpretation, meaning to the finest level of interpretation, so that you make you'll be sure that what you are talking about is the truth, nothing but the truth. And ground truthing is strengthened by laboratory work. So you collect samples and you go to the laboratory to do analysis to support the area photos that you have, so that it will aid in interpretation of what you observe in the photographs. After having established the dominant soil region during the transect work, meaning that when on the field, in order to collect data, we normally create a transect. This is a strip of land. You walk on the strip of land, you collect information as you go. And normally, we use GPS to aid us to do that. And at the end of the day, we transfer this information into GIS software to enable us to, get the spatial distribution of the soil with respect to the attributes that they have. And because we cannot cover the whole area, if you want to do a study in central region, you cannot cover the whole of central region. We do what we call extrapolation, what we call kringing. You take some few points and try to use those few points to extrapolate to cover the whole study area. And so these are some of the methodologies that we use. So somebody will ask, how can you conduct a soil survey to cover the whole country? Can you go to every village, every town? No, we try to look at the what they call the clinite variation. We look at variations with respect to geography and then environmental, what they call climatic variables, and use that to conduct some kind of extrapolation to cover a whole area. Then another important thing, which is a component of soil surveys, as I said earlier, on laboratory analysis. So you do ground truthing, and the ground truthing involves some level of laboratory analysis. So as you go along, pick soil sample, you have to also dig holes and look at the soil profile. You look at the soil katina all over the place, and use other land evaluation models to develop soil maps for a particular location during the survey process. Once the laboratory data are on file, field classification of soil profile pits can be verified, and the soil map can be finalized. And field operations, there are two methods of field survey, namely free survey and grid survey. In the free survey, the surveyor uses his judgment of the objectives of the survey in all the available area photos, ground evidence to locate profile pairs of the most useful and representative site. The number of the profile pits depends on the requirement of the survey and the complexity of the soil pattern. Then we have the grid survey. Here, the observations are made at regular intervals. So you create something like a cell on the map. You divide the cell into cells, what we describe as grids. And you either select those grid randomly to let you know what is the nature of the soil type distribution. Here, observations are made at regular intervals along predetermined transverses in the survey area. The method is specifically useful for large-scale, high-intensity detail survey and intensive surveys. So if it is UCC campus, you divide UCC campus into small units on the landscape,
in the form of a cell. Let's say, then these cells are normally described as grid. So you pick the first one, you skip the second one, then go to the third, the fourth one, you skip it, and you go to the fifth in that order. You are performing systematic sampling to acquire necessary soil information. So that is grid survey. Then advantage of grid system, the transverse provide access between roads in the dense forest. Sample points along the transverse can be located and mapped out with accuracy. Direction of the transverse can be arranged across the topographical drain of the country. So you can look at the climate changes and develop your grades. So the grades are not developed in isolation. You develop the grade based on certain attributes, observable attributes, along a river basin or along a topographic variation. So you really use that to develop the grid system. Or you can use the rainfall amount, the changes in rainfall amount to develop the grids. The greater part of the field survey can be carried out by soil survey assistants with minimum supervision by the surveyor. The transverse grids provide a uniform sample point within which it is very unlikely that important soil type will be overlooked. So that is the advantages. Then grid observation include the following: soil profile observation, which include description of the environment, general information on the soil, and brief and detailed profile description. Others include brief description and classification of chisel holes. And chisel, normally we do the chisel hole with either Uga, a special instrument. You drill into the soil, and then you get a soil core for analysis. Site description include vegetation. The vegetation can be an indicators for you to determine whether the soil is very fertile or not. So land use and slope measurement and drainage and geology information can also be obtained. Then in the survey, one of the things that we do when you develop map is what they call the scale. The scale. So if you have a map and the map say that 1 to 2 million, what's the meaning? 1:2 million. Who can explain us? 1:5 million.
Sir, please, that is the scale. So meaning one
is
sheet represents 5 million on the ground.
One
so
is
that's
to
the
what?
scale.
1:what? The first one, let's say 1:2 million. What's the meaning?
Meaning 1 centimeter that you see on the sheet on the ground represents 2 million on the ground.
No. What it means is
Sir,
that
so not the scale.
you are right, but let me you've gotten it, but the units, you do as if let me explain it to you. So if you have something like that, what it means is that 1 centimeter. Yeah, go ahead. You can help. Go ahead. This is very, very important.
Sir.
Yes.
1 unit.
Mm-hmm.
1 unit.
Centimeter on the map, on the paper that is in front of you.
1 unit.
Hello?
On the
Are you lost? Or that? Okay, let me quickly chip in because we want to go away. What it means is that the first one means that 1 centimeter on the paper.
I'm saying that 1:5 million means that no, say.
Go ahead. I'm listening. Hello. Oh, the internet connection. The lady who just spoke, let me come back again. Let's talk about this.
Hello, Prof.
Yes, go ahead. And let's get this straight. You said what? One.
I want the first one, the one.
Yeah.
That is what you represent on the paper. That is
that's
what on the paper. You
And
can't
that's
have
true.
the bigger one on the paper. So
then the 2 million is what is on the ground. Is that also?
Yes, that's what is on the ground.
Okay, so what is the unit then?
So meaning when you see CM on the paper, on the ground, it represents 2 million.
Okay, 2 million of what?
Okay, sir, let me come in.
Please, Prof, please.
Yeah,
Prof, let me come in. Sir, can I come in? Sir,
yeah,
can I
you can
come
come in.
Yeah, it
Yes,
means
please.
that 1 unit on the topo sheet represents
Yes.
2 million units on the ground.
Yeah, that is true. But then what it means is that 1 centimeter, if you have 1 centimeter, if you use your ruler to measure 1 centimeter on the ground, it represents 20 kilometers. Then the 5 million is 50 kilometers on the ground. Are you getting it? So let's say this one here, we have 1 million. What it means is that 1 centimeter on the paper represents 10 kilometers on the ground. Then, for example, you have 1 is to 2,500,000. 1 million, 1 is to 250,000. 1 is to 250,000. What it means is that 1 centimeter is equivalent to 2.5 kilometers. In the case of this one here, are you getting it? So when it comes to this one, this sorry, I say 1 meter, 1 centimeter. So you have 1 centimeter is equivalent to what? 5 kilometers. So when it comes to this one, it's basically 1 centimeter is equivalent to 1.2 kilometers on the ground. So that's the meaning. All that you people are saying, they are right, but try to get the units right. So if you use your ruler on the topo sheet or a string, you use a string. Normally, if you can use a string to trace whatever path you are interested in, when you get the measurements, maybe it's about 10 centimeters. What is equivalent on the ground in terms of kilometers? That is what it means. And then you can use that too. So these are the type of scales that we use. We have a exploratory survey scale, which are most often in higher dimension, followed by compilation. So look at the scales. Then we have the reconnaissance. Reconnaissance, meaning that you're just walking through. You are not. You are working through, and you only look at some few attributes on the field. Exploratory is rapid. Then reconnaissance also, we describe it as low intensity detail survey. Then we have semi-detailed survey, medium intensity. It's all based on the type of scale that you are using. So you have 1 is to 1 million, 1 is to 25,000. So in that case, what will be the unit on the ground? 1 is to 25,000. Yes, let's do some little bit of maths. And 1 is to 50,000. In case of this one, I said 1 is to what? 2.5. So what will be this one? Yes, it's math. So if you not say it, I'll break it in the exam. So okay. So when you have time, just try to play around this. If you really want to understand it, copy these skills and then put them in your search engine, your Google search engine. If you have access to internet, it will give you the interpretation. So as we look at the skills,
defines the kind of surveys that we conduct on the ground. So we have semi-detailed survey, detailed survey, and all is based on what? The skills that we have. So please take note of the skills. So intensive skills, typically 1:5,000. Then you have 1:10,000, 1:2,500 to 10,000. That tells you that the grades are very, 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 very small on the ground. The grades are very, very, very small. So the cells that you create to collect your samples, they are very, very, very small. So, and this is more intensive because they are small. You can do a detailed analysis of the area. So if you have maybe a whole of Cape Coast, you go to and then you go and pick only one point. How can that be representative of the whole of Cape Coast? But in this case, because the cells are very small, like this one, you may have a series of cells, and each of these cells you may decide to pick a point and a sample from there, and then you analyze it. So it gives you a detailed information. The grid or regular transfer methods of field surveys are used. Mapping units are soil series and phases. So I think I don't know whether I have to pause here. So these are the summary of all that we've done. So exploratory, we have this skill, establish major soil regions, reconnaissance, systematic line resource inventory. Then semi-detailed, we have project feasibility study, there are applications, land use development. Then we also have, what do you call it? So now the purpose of the soil survey is basically for agriculture, forestry, engineering, urban development, recreation, etc. So then transferring technology by correlating the characteristics of soils, of known behavior, and predicting the adaptability to various uses. So the purpose is in detail. Please, I want to pause here. When you have time, you read the rest, okay, on your own. So these are the, so the purpose, you can read it on your own. Let me pause here and allow you to go. I'm going to upload the slides on the platform, then you do a detailed study on your own. So let me stop my presentation. Where are we? So what should I say? Stop the presentation. Okay. So Cedric Bonse-Mensah has left the meeting. Ebenezer Pokwamwa, you've left.
Yeah.
What I'm going to do is I'm going to upload those onto the platform. Unless you may have a quiz next week or something. So I want to look at the areas that I'll cover in terms of the quiz. Then I'll let you know, because within 4 weeks, it's very, very difficult for you to absorb everything. So I'll let you know. I basically, I'll set about 40 objectives or 20 objectives. So you may have options to select from. But in the case of your end of semester, I will set 20 objectives, then 4 questions. The 4 questions you select 2. The objectives will be 20, and the 4 questions you select 2. Each of them is 20 marks, and that will be that will sum up to 60. Then the continuous assessment will be 40 marks. So the 2, when we sum them up, will give you your grade. So now, not if there are no other questions, I have to let you go. It's not 15. I think 9:15 a.m. See you. If you have any issues, you can WhatsApp me and let me explain it to you. So I'm going to put the last slide on your platform right away. So bye-bye.
So, sir.
Yes.
Please, we need some past questions. Can you please paste some past questions for us?
Yeah, well, I'll send. I have a lot of it out there, so I'll send it to you.
Okay,
That is
we
for
shall.
me.
Oh,
But that
definitely.
is-
Once we get them,
I
we
will send
will tackle.
standard questions from the regular program.
Okay.
Then I also have some past questions from the other code. I think you have two types of code organized program. This one and another one. I don't know how you call this one. What is the name of this one?
Switch.
Then there's another one too. So I will just send you the sample questions that can guide you as to how to study.
Thank you, sir.
All right then. Bye bye.